Hey guys, today I'm going to teach you how to solve systems of equations by elimination. By the end of this lesson, you'll be able to use the elimination method to solve a system of equations. This is the third and final method of solving systems, and I love this method. So go ahead and make sure you get your binder out, turn to the math section, and get ready to take some awesome notes. All right, so before we get started, quick review. We solve systems of equations. The solution to a system is where the lines intersect. On a graph, we can plot the two lines by starting at the y-intercept of the first line, plotting a point there, and then counting the rise over run, which is the number next to the x, that's our slope. And the slope tells us how to move on our graph, so I count from point to point based on that. It's a little messy, it's not perfect. I look at the second equation, it's y equals 4, so it's 4 the whole time on the y-axis. That makes a horizontal line on 4, and then my solution's where they intersect, right here. So if you don't have graphing paper or a graphing calculator, that might not be the best method to solve this system. So we taught you how to solve by substitution. This is the really algebra-heavy strategy where we use substitution to solve the system. So we saw like y equals 4 in one equation. So if y equals 4 here, then this y equals 4. And we could solve this first equation as 4 equals negative x plus 1. We draw our line on the equals. You could subtract the 1 from both sides, end up with 3 equals negative x, and then realize this is something as negative 3 equals positive x. So we found our solution, negative 3, 4, by substitution. And some people don't like that method. It's a little difficult for them, and sometimes it's not the best. That's why we have elimination. Elimination method is the easiest method as long as the two equations look like some of these ones below. So check out number 1 and number 2 before I start explaining this to you. Look at number 1. These two equations have the x's lined on top of each other and the y's lined on top of each other on the same side of the equation. The same is true on the right here on number 2. The x's are lined up and the y's are lined up. When you have two equations that are lined up like that, it's almost like you would line up decimal places in like 6th grade math or 3-digit and 3-digit operations. You're just adding and subtracting. So let's go ahead and let's get into this and let's show you exactly what this means. So first of all, it says in cases where the variables in two equations have opposite coefficients. Let's make sure we understand what coefficients are. Coefficients are all of the numbers next to the variable. The coefficient is the number next to the variable. It says if they're opposite coefficients, that means that they have negative and positive signs. So like, for example, in the first one, negative 4 and 4 are opposite coefficients. In the second one, 6 and negative 6 are opposite coefficients. They're the same number, but opposite signs. It says if we have that, we can solve the system by elimination with the following steps. So let's go ahead and get into it. Number 1, line up the like terms in the equations. Like terms means that x's line up with x's, y's line up with y's, and your numbers line up with numbers on the far right. Number 2, we are actually going to be able to add the equations. By doing that, we'll eliminate one variable and we'll solve for the other one. Let's go ahead and jump right into this and look at number 1 here. When I look at number 1, I have two equations. They're already lined up. X's are on top of x's, y's on top of y's, and I have opposite coefficients, a 4 and a negative 4. I'm going to do this just like I would like you're adding 3-digit and 3-digit in 6th grade math. You draw your line and you put a little plus sign. When I do this, I want to just look at their coefficient, negative 2 and 3. I can add negative 2 plus 3. That gives me 1x, and I keep the x now. Now I have positive 4 and a negative 4. Those two things cancel. When they're opposites, I just put a slash through them because they are canceled out. That makes 0. I'm going to bring down the equal sign, and I'm going to do 4 plus 2. 4 plus 2 is 6. At this point, I don't have to do anything else. I have already just found x. 1x equals 6. So just by using this elimination method and adding the two equations, I found that x equals 6. Now I'm not done yet because a solution to a system has an x and a y. I need to know what the x and the y equal. So let me go ahead and move on to step number 3. For step 3, you will actually have to substitute one time. You have to substitute your answer for x into one of the original equations to solve for the other variable. So take this x equals 6 and just put it to the side. Now I know that if that x equals 6, then so does this x and so does this x. So I'm just going to pick either one of the equations. I'm just going to pick this one, and I'm going to substitute in a 6 for the x here. So I'm going to rewrite the second equation. All I did was rewrite this equation, but instead of writing an x, I wrote a 6. Now I just need to simplify. 3 times 6 is 18. Now I have a two-step equation. it's a positive 18, so I'm going to subtract that from both sides. I have negative 4 times the number equals negative 16 now. So it's a times negative 4, so I'm going to divide both sides by negative 4. Negative 16 divided by negative 4 equals positive 4. So when x equals 6, y equals 4. And that's my solution to the system of equations. When I've found the x and the y values, I'm going to move on to the very last step. I'm going to write my variables as an ordered pair. That means x comma y. So 6, 4 becomes 6 comma 4 as a point, because that ordered pair is the point where these two lines would intersect. And I can always check my answer by plugging in the x of 6 into the original equation and the y of 4 back into the original equation. When I plug in x is 6 and y is 4 in the first one, it should equal 4. When I plug in x is 6 and y is 4 into the second one, it should equal 2. So there you have it. That's how you solve a system of equations by elimination. You line up the terms in the equation, you add the equations to eliminate one of the variables, and you solve for the other. Then you substitute your answer into one of the original equations, just like we did here when we found x equals 6. We substituted that in and then solve for the other variable. When you get that done, you write your answer as an ordered pair and you check your answer to make sure. So let's go ahead and try number 2. If you feel comfortable with this, go ahead and try this by yourself and then press play whenever you're ready to check. Okay, if you're not feeling so comfortable with this, or you're ready to check right now, I'm going to go ahead and just go through it one step at a time. So first of all, the first step says line up the terms in the equation. The like terms are already lined up. X's are on top of X's, Y's are on top of Y's, and numbers are over here on top of numbers. So step 2 says add the equations. So I'll draw the line like I'm adding, like I would 6th grade math, like 3-digit and 3-digit. And then I'm going to eliminate the variable that cancels out. So the X's here cancel out because they're opposite terms. 6 and negative 6 are opposites. So I'm going to cancel those and just put a line through them to show that they cancel. And then I'm going to add the rest of the coefficients. So 2 plus negative 5 gives me a negative 3. And I'm going to keep the y. 4 plus negative 28 is something as 4 minus 28. And that gives me negative 24. When I have a one-step equation written like this, I need to realize that since it's negative 3 next to an x, that means it's multiplying. It's negative 3 times that number equals negative 24. The opposite of a times negative 3 is to divide by negative 3. So I'm going to divide both sides by negative 3, and I'm going to end up with y equals 8. Now that I know that y equals 8, I'm just going to put the information over to the side here, and I need to solve for the x. So step 3 is to substitute my answer for y equals 8 into one of the original equations. It doesn't matter which one you pick. I like to pick the one with all the positive numbers because I like positives more than negatives. I think that's easier. So I just picked 6x plus 2y equals 4. And instead of writing a y, I'm just going to write it as 2 times 8 instead of 2 times y. So I have 6x plus 2 times 8 equals 4. I can simplify 2 times 8. That gives me 16. So I have 6x plus 16 equals 4. Now I have a two-step equation to solve. Since it's add 16, I need to subtract 16 from both sides. I'm left with 6x equals 4 minus 16, which gives me a negative 12. And then I'm thinking, what number times 6 gives me negative 12? Since it's x times 6, I can divide it by 6 and do that to both sides. When I do that, I get that x equals negative 2. So then my last step is to write my variables as ordered pairs and then check my answer. The final solution to this system of equations is negative 2, 8. And when it says check your answer, you could plug in the negative 2 in for the x in the top one, the 8 in for the y in the top one, and you should get 4. Do the same thing in the bottom one, and you end up with negative 28. Another way you could check this would be to plug it into your calculator and graph them, because we know how to solve systems by graphing, and you'll get the same solution. The lines will intersect at negative 2, 8. You could also solve this by substitution if you had one of these variables set to like a y equals or an x equals. But since you don't, elimination really is the best way to solve this system of equations. So you should be filling out those check boxes with your checking your work, but I'm not going to just to save time here. But you should be doing that every time you see a system of equations. It's an easy way to check it and make sure that you get the right answer before you put it in or write it down on a test or quiz. Okay, so on number 3, you have the same situation. Go ahead and try this one by yourself for sure, using the same steps that we just followed, and then press play whenever you're ready to check, and I'll be going over it with you. Okay, so you should have just tried that by yourself. First step is to line up all of our terms. Our like terms are already lined up. The next step, I'm just looking at my list, add the equations to eliminate one variable, and then solve for the other. So I'm going to add these up just like you would a 3-digit and a 3-digit. When I did, I got 10x equals 30. And then you want to divide both sides by 10 since it's being multiplied by 10. So x equals positive 3. Now I want to go back to my instructions and I want to substitute my answer of x equals 3 into one of the original equations to solve for the other variable. I just chose the second one. You can choose the first one. You'll get the same answer. So I put in a 3 for the x, and now I'm just going to simplify and solve. 6 times 3 is 18, plus 7y equals negative 17 is a two-step equation. After I solve that, I end up with y equals negative 5. My last step tells me I need to write my variables as an ordered pair and check my answer. So instead of writing x equals 3, y equals negative 5, I'm going to write that as a point. 3, negative 5 is the solution to this system of equations. If I graphed it, that would be the point where the two lines intersect. And I would challenge you to check that by graphing or by substitution or some other method like plugging these numbers back in here just to make sure that you got that answer correct in this space. All right, so let's do the very last one. Please make sure you're trying this next one by yourself all the way through and then press and play whenever you're ready to check it. I'm going to go through this one pretty quickly. Okay, so I got them lined up. I'm going to add. The x's cancel. 2y plus 5y is 7y. And 18 plus 45 equals 63. When I solve for y, I get y equals 9. I'm going to plug that value of y equals 9 into either one of these equations. I'll pick the first one. I got to this step. I plugged in the 9 in for the y. I got 5x plus 18 equals 18. I'm going to subtract 18 from both sides, and I'm going to end up with 5x equals 0. When I divide both sides by 5, I end up with x equals 0 divided by 5, which is 0. It's okay to get x equals 0. That's fine. It means that the point that this is crossing is actually going to be on the y-intercept of 9. So the point where these two lines intersect is at 0, 9. All right, so hopefully you like this elimination method now that you can cancel out a common term. However, sometimes, look at number 5 here, they don't cancel immediately. So look here, there's a negative 1 and a 2, there's a 2 and a 3. Nothing automatically cancels out. If something doesn't automatically cancel out, you can still solve by elimination. You're just going to have to manipulate the equation a little bit before you can get started. So here's one extra step just in case you're looking at like number 5 or number 6, where these equations don't automatically cancel out. In that event, you're going to want to multiply one whole equation by a number in order to create opposite terms. So you're going to have to create the thing that cancels out. So look at number 5 here. I do see a negative and a positive. The x's do have an opposite operation here. There's a negative x and a positive x. However, I need this one to be negative 2 for it to cancel out with a positive 2. If I need that to be a negative 2 to cancel out with a positive 2, I can make it a negative 2. I just have to multiply the whole thing by the number 2. So let me show you what that does. I'm going to rewrite this right underneath of this. So I'm going to rewrite it in this space underneath of this second equation, but it's going to be the same one as this one. It's almost like I'm going to distribute that 2 to each of these terms on the inside. So 2 times negative x is negative 2x. 2 times 2y is 4y. And then 2 times negative 13 is negative 26. This equation I just wrote is the exact same thing as this one up here. It's just all been doubled. And the reason I did that is so that I can ignore this top one now and just focus on these two equations. And now I can cancel them out using my elimination method. I wanted to do that because I wanted to cancel the x's. I need something to cancel because when that cancels, I'm only left with one variable to solve for. So now I can just follow the steps that we just did here. So I lined up my like terms in the equation. I added the equations to eliminate the one variable. The one variable I eliminated was the x's. 2 and negative 2x cancel out. So now I have 4 plus 3y, so that is 7y, and that equals negative 14. When I divide both sides of the equation by 7, I end up with y equals negative 2. Now remember, the next step would be to go ahead and substitute my answer into one of the original equations. You can choose whichever equation you want, the manipulated one, the original one, or this one. It doesn't matter which one you choose. I'm usually going to just choose this one like I just did in red here, because that one is the one that's like not messed with. It's the smallest one, and it's the easiest to work with. So I'm going to put in a y equals negative 2 in for the y in that equation, and then solve for x. When you do that, you should get an x equals 9, and so your y is still negative 2. And that's the solution to the system of equations here. So this method is a little bit trickier if something doesn't automatically cancel, but it still works. You just have to manipulate the equation so that it does work. Let's do one more. Let's look at number 6. Look at the two equations. See if you can figure out what you need to get to cancel. I see a positive 4 and a negative 2. I know that if I can get this second equation to have a negative 4 next to the x, then I can cancel out the x's. So to get this to be a negative 4, all I have to do is multiply that whole second equation by 2. If I double negative 2, I end up with negative 4. So underneath of it, I'm going to multiply each of these terms by this number on the outside. It's almost like I'm distributing. So negative 2x times 2 is negative 4x. Negative 5 times 2 is negative 10y. And negative 29 times 2 is negative 58. When I have them written like that, I can ignore that second equation. I'm just going to look at the first one and the newly manipulated equation. Then I'm going to add them and cancel out the x's. When I do that, I have negative 11y equals negative 77. I realize that y equals 7. And I can solve for x like I did, like normally. When you do that, x equals negative 3 and y equals 7. So just a second before I quit for the day, let's look back at this. When we solved systems of equations, we had 3 different methods. The first one was graphing. When you had these two equations, they're both in slope-intercept form. That might be the best method for you if you have a graphing calculator or you can confidently graph these on a coordinate plane. Substitution was another way because you could just plug in when y equals 4 for y in the first equation. Elimination wouldn't be the best strategy for this one because they're not lined up. So as easy as elimination was at first, elimination doesn't work every single time. That's why you have all these other methods that you can use. So now that you have 3 different methods to solve a system of equations, and then you also can look at it by inspection, I want to make sure that you understand that you are going to now decide which method is best when you solve systems going forward. All right, guys, that's it. If you made it to the end of this video, please put in the comments your favorite cookie. Today, we learned all about solving systems of equations by the elimination method. Now, you should be able to use that method to solve a system of equations whenever the variables are lined up just right and a coefficient can cancel out with another coefficient, and you can solve it really, really quickly and easily. Now, you should go back to your calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.